Let's evaluate logarithmic expressions. For example, let's evaluate log base 2 of 32. Now we have the following definition of the logarithm, that log base a of x is equal to y if and only if a raised to the y power is equal to x, where a and x are positive and a is not equal to 1. That is, the answer, y to a logarithm, is the exponent that we need to raise the base to get what we're taking the logarithm of. Let's apply this here. Namely, let's let y equal log base 2 of 32, which is what we're looking for. And by this equivalence over here, this means that the base, namely 2, raised to the answer y, is equal to what we're taking the log of, namely 32. So we have to ask ourselves, what power would we need to raise 2 to get 32? And that power would be 5, wouldn't it? Since 2 to the 5th power is equal to 2 times 2 times 2 times 2 times 2, 5 times, which is equal to 32. Therefore, log base 2 of 32 is 5, which would be our answer. Let's look at another example. Let's evaluate log base 16 of 1/4. Again, we're going to let y be equal to what we're looking for, log base 16 of 1/4. And by our equivalence over here, this means that the base 16 raised to the power y is equal to what we're taking the log of, namely 1/4. Now 16 is a power of 4. In other words, we can rewrite this as 4 squared raised to the y-th power, and we can also rewrite 1/4 as 4 raised to the negative first power. By properties of exponents, we can multiply the exponents on the left, so 4 raised to the 2y-th power is equal to 4 to the negative first power. And now these bases are equal, which means these exponents are as well, which is a direct result from the fact that exponential functions are 1 to 1. That is, 2y is equal to negative 1, or dividing both sides by 2 gives us that y is equal to negative 1/2, which would be our answer here. That is, log base 16 of 1/4 is equal to negative 1/2. Okay, let's look at one more. Let's evaluate log base 27 of 9. Again, we'll let y equal what we're looking for, this log base 27 of 9, and converting to exponential form gives us 27 raised to the y-th power is equal to 9. Now both 27 and 9 are powers of 3. In other words, we can rewrite this as 3 cubed raised to the y-th power is equal to 3 squared. Again, by properties of exponents, we can multiply the exponents on the left, so we have 3 to the 3y is equal to 3 squared. And again, now that these bases are equal, these exponents will be as well. That is, 3y is equal to 2, or dividing by 3, we get y is equal to 2/3, which means that log base 27 of 9 is equal to 2/3. And this is how we evaluate logarithmic expressions. We convert to the equivalent exponential form. Thank you, and we'll see you next time.